Hi, this is Mrs. Thompson. In our last video got a little soft. I think my voice, I was a little farther away from the microphone, so I'm going to try this again. Hope to post it and have it up for you. Here you can see our definitions of square root. B squared equals A. B is the square root of A. So I give you a couple examples. 3 squared equals 9. 3 is the positive root of 9. Negative 3 squared is also, negative 3 is the negative square root of 9. In class the other day, we talked about our different roots. We talked about the notes that you're going to be filling in, the radicand, or radical symbol, and that the radicand is the number that's underneath your symbol. If you're thinking of the word simplify and evaluate, we talked about this a little in class. Simplify is just simply to replace with a single number value. This is when you're going to have a single number value. Or single, my writing with this pad is not that great. A single number value. So if you think of it, this is where you're simplifying your equations. We simplify, get it down, you're using your order of operations. When you evaluate, usually you're going to have an algebraic expression, and when you look at that algebraic expression, you are going to be substituting numbers in and solving that expression. So you would plug a number in and you would simplify after you plug the numbers in. So simplify after replacing the number values for the variable. Some of the other ones that you're not going to see so much in your notes, but will be part of your lessons that we're going to be talking about, is the word set. And set is just a well-defined collection of objects. So a well-defined, in this case, collection of objects. When you think about a subset, those are the smaller groups of the sets. So a subset consists of all the elements of that given set. An element of a set is just the object in the set. So simply those objects. Again, these are all in your vocab in your book if you want to look at those. Equivalent, inequality, all of these different properties, those are going to show you a little at the end of the video. I also talk about how you can make a flashcard or a flip card for notes. So we'll look at those also a little later. Deductive reasoning, counterexample, those are in the video. Absolute value, you should know that. That is the distance from zero. So absolute value, the symbol we use, if you remember, are the two straight lines, and that's simply the distance from zero. Opposites, when we think of our opposites, that's when two numbers that are going to be, if they are opposites, they are going to add to zero. So they have the same absolute value. Opposite numbers will have the same absolute value. Inverse property of addition. When we talk about our inverse property of addition, what we mean is that the sum of two numbers, the number and its inverse. So if we find the sum of a number and its inverse, it has to always be equal to 0. So if we think about that, that's when you add 7 and negative 7. And 7 plus negative 7 equals 0. Number and its opposite is always going to equal 0. And subtracting real numbers, the key thing that we want you to be thinking about anytime you subtract is subtraction is going to change. Subtraction changes to adding the opposite. Subtraction is always going to change to add the opposite. And I know you did this quite a bit last year in pre-algebra. We're going to continue that. But remembering that if we want to have it in simplest form, sometimes we might use subtraction instead of plus the opposite. Again, the radical symbol you're going to see, your perfect squares we talked about in class, you really should memorize the first 12 perfect squares. And remember, the perfect squares are these numbers. Not the 10 squared, but the 100, the 1, the 4, the 9. These are your perfect squares that we are talking about. When you take a look, as you filled this part in, we kind of talked about estimating our square roots. Here's your first perfect squares. Again, as we talked about, square root of 12, well, where is that? It's between 9 and it's between 16. So which is it closer to? If we look at 87 and the square root of 9 is 3, and the square root of 16 is 4. So which number is it closest to? We know it's going to be between 3 and 4 is our square root 12. 87, well, we have 81 and we have 100. It's a lot closer to 81 than it is 100. So the square root of 81 is 9. We'd say the square root of 87 is probably going to be pretty close to 9, not as close to 10. 49 is exactly at 7, and the square root of 34 would probably be closer to 6 than to 7, 6 than to 5. So square root of 34. So knowing those perfect squares can help you with that. We've talked through the sets of numbers. This is really important. I'm going to show you all the sets. Real numbers is every number in our number line. Then we start getting more specific with our rational numbers. They are numbers that end or have a repeating pattern. When you think of a rational number, it can always be written as a fraction, a over b, as long as b is not 0. Remember, you can never divide by 0. What are our integers? Well, they have no decimal parts. Integers can be positive, negative, and 0. It's kind of your whole numbers, 0, 1, 2, 3, ... and their opposites. If we're talking about whole numbers, those are the non-negative integers, 0, 1, 2, 3. And the natural numbers, I like to also think of those as our counting numbers. So natural and counting, when you start counting, you usually start with 1. Here's just kind of asking you to place this. We'll probably take a look at this in class and see if you can place it. Some of them fit into many categories. Here's where we talk about what is an element of a set and the subset and the definition of the word set. So if you need to pause it on this page to write in those definitions, you could. We talk about the natural numbers as a set, whole numbers, integers. We talk about a rational number being the fraction. And then we also talk about that it ends, terminates, or it repeats. As we look at irrational numbers, irrationals are numbers that we can't write as a fraction or the quotient of two numbers. They never end and they never repeat. So pi, square root 2 would fit into those. If we're thinking of 3/10, it is not a whole number, it's not an integer. It is rational, but it is not irrational. So all of these would be it is not. I think I'm only going to put the check mark for what it is. Negative 0.45, not a whole number, not an integer, it is rational, not irrational. Square root 12 would only be irrational. So we're going to talk more about those in class. Here you're asked to classify these numbers, so if you kind of take a look at this page and think which ones are our rational up here that are also an integer, also a whole number, and also a natural number. 5 fits in all of these. The ones that are irrational is thinking of our ones that never repeat and never end. You should know how to use your calculator to approximate the square root, so make sure you know how to use your calculator. That's going to be important in tomorrow's class. We're going to be asked to classify, are they rational or irrational? Well, square root of 100 is 10. That would be rational. Square root of 0.29, you put it in our calculator, it is irrational. As we are looking at that. Never repeats, never ends. We're going to talk about algebraic and numeric expressions tomorrow in class. What is an equivalent expression? Again, in your notes, you might want to pause and get this page down. Deductive reasoning and counterexample. We're going to be using these throughout the year, so they kind of are in this chapter and we go rather quickly over them. Here is a list of all of the properties. Now when I talk about all the properties, these are the beginning algebra properties. Commutative property, both addition and multiplication, associative, multiplication and addition, distributive, additive identity, multiplicative identity, additive inverse, multiplicative inverse, and the zero property. I'm going to show you this what's called the foldable notes, and it's a nice way of setting up your notes so that on the inside you can put what the properties are and what it means. So commutative property really means we can change the order around and it doesn't change our answer. That's for both addition and multiplication, whereas associative property is moving the parentheses. We'll talk more about these foldable notes tomorrow in class. If you were going to match the property to the statement, which we'll be doing more practice of in class, I would like you to do that right now. Pause the video if you need to before you connect them. So I'm going to give you the answers as we are looking at these. Commutative property of addition is right across here. They're giving you each property as they are. In this next part, they're asking you to match them. So if you were going to match these two properties, and tomorrow in class we'll be talking quite a bit about which one are these properties and matching them and understanding them. Absolute value, again, that's in your notes that you want to look at. Remember, it is the distance from that number to 0. So usually absolute value is positive. We talk about our rules for addition. You add the signs of their absolute values if they have the same sign and keep the same sign. So -7 plus -3, keep the same sign. 7 plus absolute value of 7 and 3 is 10, -10. But when the signs are opposite, we actually subtract the larger absolute value from the smaller. So -7 plus 3, we actually want to take 7 minus 3, which is 4, keep the larger absolute value, which is negative. If we would have had 7 plus -10, we're going to actually subtract, as the rule says, and this time when we think of the larger absolute value, 10 is a larger absolute value, so we would have a -3 for our solution. Your notes, I handed these out in class. We're going to talk through these tomorrow in class as you look at them, so you should be able to do the 1-1 notes. You should be able to have filled in the 9-2 looking at these, and we'll answer some questions. Circling your rational and irrational numbers down here, circling all the irrational ones. And we, again, if it helps you to put those little extra notes that we talked about, repeating and not repeating, you might want to put that behind there. We'll also look at the properties and matching those up to the different expressions. What property is being illustrated? And then the last part is simply doing our addition and subtraction with our integers. I hope this video was a little better than the last one and that you can hear me. Have a good night.